Alright, so today's lesson, 7.4a, the double angle formula. Double angle formulas. Double angle formulas. So, before I just go ahead and tell you what the formula is, remember the problem that we had when we were dealing with the sine of 15, the sine of 75, or the tangent of 75 degrees, things like that. There were some angles that we could not just take the sine and cosine of and get an exact answer, okay? So the sum and difference formula were able to help us out with that. The double angle formulas are going to do the same thing. So this is the case where maybe we have some angle. We are going to be able to find what is the sine or cosine of something that's twice that big or half that size or whatever. So let me just get started here. Sine of 2 theta. Let's say I want to know what the sine of double some angle is. And what we're going to do is we're going to rewrite that in the terms of something that we already do know, which is sine of theta plus theta. Now you know how to handle that, right?
That's what we worked on Friday, right?
Absolutely. So yeah, your trig chart, let's read off to me. It's going to be real easy. Both the u and the v are both theta. Sine theta, cosine theta, plus or minus? Plus. I need to verify. It is a plus. And then cosine theta, sine theta. Yeah, the sine is the one that alters. Cosine, it's sine times cosine, cosine. Okay, so sine theta, cosine theta plus cosine theta, sine theta. Well, it's the same thing, correct? So it turns out that this would just be 2 sine theta, cosine theta. And that's the first double angle formula. That the sine of twice an angle is equal to 2 times the sine of that angle times the cosine of that angle. Let's see if we can do just a little short example, maybe to prove it here for you. According to that, the sine of 2 times 30 degrees should be, if we are correct, 2 times the sine of 30 degrees times the cosine of 30 degrees. So in other words, the sine of 60 degrees should be 2 sine 30 cosine 30. So and we can check these each independently. What's the sine of 30? Those of you with the trig chart out. Sine of 30 is 1/2. What's cosine 30? Root 3 over 2. We also have this one that we can verify with the trig chart. What's the sine of 60? Root 3 over 2. So, if you look, 1/2 and the 2 cancel each other out, and we have root 3 over 2 equals root 3 over 2. Okay? So what this is going to allow us to do is going to be able to help us find angles here or angles here if we know maybe one side of that equation or the other. And we'll do some problems like that here in a minute. But do y'all see how this verifies that fact? 30 and 60 is the easiest ones to double check it with. Alright. Well, now we're going to do the same thing but with cosine. So our cosine formula, cosine 2 theta, is going to be cosine of theta plus theta. So somebody read off to me what was the sum formula for cosine. So cosine theta plus or minus? Minus sine theta times sine theta. Alright? So if you remember, if you have cosine times cosine, one way that you could write it would be the quantity of cosine squared, but that is not how we write it. Okay, cosine squared theta. We write it as cosine squared theta, that's correct. Minus sine squared theta. So cosine 2 theta, so cosine of twice an angle is equal to, just take the cosine of that angle squared and subtract that from the sine of that angle squared. Thing is, there are actually other versions of this. Okay? We can manipulate it slightly. And remember that Pythagorean identity? I'll put it over here on this other board. The Pythagorean identity, it was sine squared theta plus cosine squared theta equals what? Equals 1. So from that, we could say that sine squared theta equals 1 minus cosine squared theta. Would y'all agree with that? So we can go over here and we can keep the cosine squared theta, but instead of saying sine squared, we're going to replace that with 1 minus cosine squared theta. So 1 minus cosine squared theta. So this turns out to be cosine squared minus a negative cosine squared, so it turns out to be plus. So that's 2 cosine squared theta minus 1. So that's one version up here, cosine squared minus sine squared. Here's another version, 2 cosine squared theta minus 1. But there's a third one as well. And that is, I'll kind of start off where that one was before. It is possible to solve this equation over here, this Pythagorean identity for sine, but I just as easily could have solved it for cosine. Notice cosine squared theta equals 1 minus sine squared theta. So going back to this one, I'm going to replace the cosine now with 1 minus sine squared theta. So 1 minus sine squared theta minus sine squared theta. So that turns out to be, I guess we put it this, minus 1 minus 2 sine squared theta. So there's actually 3 different versions of this formula. Cosine 2 theta could equal cosine squared minus sine squared, or it could equal, well, it does equal this, 2 cosine squared minus 1, or 1 minus 2 sine squared. And you say, well, how do I know which one to use? Well, it just depends on what you're given. If you're given cosine and sine, well, then just plug in again and go with that. If you're given cosine, maybe utilize this. If you're given sine, utilize that formula. And we can plug in 30 and 60 and see what's going on here, but are y'all okay? Does that seem reasonable to you? We just want to get some practice problems here in a minute. Okay? Well, good news. That's 2 out of our 3 formulas. Ready for the third one? You'll never guess what it is. Tangent of 2 theta. Okay, you did guess it. Sorry. All right. So tangent of 2 theta equals, we'll start off same way as we did before, theta plus theta. And then we'll plug it into our formula. So I believe it was tangent theta, was it plus or minus right here? Look on your trig chart there for the sum formula. Plus, okay. So tangent theta plus tangent theta all over 1 minus tangent theta, tangent theta. It's really nice when everything is theta. You know, you don't have to keep track of which one's C, which one's V. So pretty much just a 1-step derivation here. Tangent of 2 theta is tangent theta theta plus tangent theta, that's 2 tangent theta, divided by 1 minus tangent squared theta. Put box right on that. And you say, well, couldn't we use a Pythagorean identity to replace the tangent with like the 1 minus secant? You could, but that's really not done. This is pretty standard right here. Question, can you find these formulas on your trig chart?
Yes.
They are, yes. Second column, I believe. There you go. So the double angle formulas. The problems here are a little bit different. They're a little strange. We'll see if we can solve them here. All right. So the instructions say use a double angle identity or double angle formula to find the exact value of each expression. Okay. So this is cosine of theta is equal to square root of 5 over 5. You say, well, how did they figure out this? Well, maybe there was a triangle out there, the Pythagorean theorem, you know. Cosine is what? In terms of x, y's, and r's. X, y over r. X over r, okay? So we've got some triangle that has the square root of 5 for its x value, and 5, so we've got something like that, and it has some angle theta. And then they've doubled this, okay? We want to figure out where we're going to end up. Now this says that theta is between 270 and 360. Well, how is that the case? Oh, okay, well it says square root of 5. They're saying 270 and 360, so actually the triangle is not here. The triangle is down there. And on these, you definitely want to draw the triangle just to get an idea here. So this is 5, that r value. This is the square root of 5, and just as an idea. There's theta. So we're going to try to double this, and we want to figure out when we double it, what's the cosine. Okay? So what's the cosine of 2 theta? Let's think about this for a second. Which quadrant do you think, when we double this angle, which quadrant do you think we're going to end up in? Think in the second? All right. Could we land in the first? Possibly. Could we land in the third? Not sure. Okay. Could we land in the fourth? Well, we know that we're in the third quadrant right here, correct? Okay. So that means we have to be at least bigger than 270. What's 270 times 2?
540.
540. Where's that? And we don't know. We're not so good on this. All right, let's start tracing along here. So there's 360. What's 360 plus 90?
450.
450. Okay, let's add another 90 to that.
540.
540. Okay. All right, so 540 is right here. What's down here? So add another 90 to that.
630.
630, and then 720. So if we're going to double this, we're at least going to be past 540 because 270 doubled would be 540. So we're at least looking at possibly third quadrant, and what's 360 doubled?
720.
720. So let's answer this question again. What quadrants could my answer be in? Third or fourth? Yeah, well, I think it's not the answer, but it's double thing. So one way you could also write that is like this. That 2 theta is between 540 and 720. That's helpful because it's going to tell us if might help us give us some idea on the angle. Okay, but forget all that. Let's just let's write down our formula. Cosine of 2 theta. Well, that's the funky one with 3 different formulas. Which one should I use? The plus one? I don't think any of them have a plus.
The 2 cosine squared minus 1.
Yeah, that one. Why did you pick that one, Josie?
Because we already have cosine.
Yeah, because we already have cosine. Okay.
Okay.
That one right there, 2 cosine squared theta. Because we already have cosine. We don't want to mess with, you know, having to figure out what sine is, so we plug it in. We should use this one right here. So what that really means is, just as a reminder, that means 2 cosine of theta squared minus 1. I'm going to write it in that way because when I do my substitution, it'll make a little bit more sense. So 2 cosine of theta up there, I'm told is square root of 5 over 5 squared minus 1. So that's going to be 2 times 5 over 25 minus 1. So that's 1/5. So we have 2/5 minus 1, which is
Negative 3/5.
negative 3/5. So we would say that's cosine of 2 theta. So this would be the x, and that would be the r. So negative 3 for the x would be over in this direction, and 5. So we'd have something kind of like this, you know, negative 3 and a 5. So that negative means I'm in the 3rd quadrant. Is that a possible answer for us? Yes, absolutely. Okay, so final answer there, negative 3/5. Like I said, it's a little bit weirder. We do not need to do this sort of analysis at the beginning, but it does help to be able to check to make sure our answer is right. In this case, we could have a negative x or a positive x. I guess doesn't really limit very many options there. All right, let's try one with sine. Sine of theta is 3 over 5, and theta is between 0 and 90. Find cosine of 2 theta. Okay. I think we'll have something really helpful here. Sine of theta is 3 over 5, and we are in which quadrant?
In the
First quadrant. So we'll go ahead and make a little picture here. 3 for the y value, 5, and there's theta. When I double it, which quadrant am I going to be in?
Second.
I'm going to be in the second. If you just think, multiply this by 2, multiply this by 2, well, 0 times 2 is still 0. And multiply this by 2.
So first then second.
Ooh, yeah, I guess we could be in the first quadrant still, couldn't we? Like, what if theta was 5? And you double it, it's just going to be 10. So, all right, so maybe that we might be in the first quadrant. The point is, what sort of answers are we looking for a cosine of 2 theta? If we could be in the first quadrant or we could be in the second quadrant.
Maybe double that 92.
Yeah, sorry. If our angle is first or second quadrant, we're not sure which. What kind of cosine values are we expecting? Positive or negative?
Positive.
Positive or negative. Right. So like I said, you might think, oh, this is going to give us some limitations. We know if we get a negative answer, we're wrong, or we know if we get a negative answer, we're right. But in this case, it really doesn't help us out. Sorry. Okay. Let's write the formula down. Cosine of 2 theta. Which one should we use this time?
1 minus 2 theta sine squared.
Is it 1 minus 2 sine squared theta?
Yeah.
Okay. So at this point, I think y'all are fine as long as you can just substitute in properly. So 1 minus 2 times 3/5 squared. So 1 minus 2 times 9 over 25. So that's 1 minus 18 over 25. Y'all can probably do that one in your head, right?
7 over 20. Negative 7 over. Wait, yeah, wait.
it's 25 over 25.
Yeah.
So you're right the first time. It's
Yeah.
going to be 7 over 25.
Yeah.
Does that match our expectations of either being positive or negative? Yeah, it works. I mean, that's.
Should have been positive
Is there a better way that we could check this?
to change this.
Okay, yeah, calculator. All right, yeah, just kind of pull that out. Okay, well, how's the calculator going to help us out? Switch to degrees. There is a way the calculator can help you. Okay? Could you figure out what theta is from that statement right there? If I told you sine of theta is equal to 3 over 5, could you tell me what theta is?
Yeah, because you can do it.
You could do the inverse sine. Okay, so let me show you how to check it. So the inverse sine of 3 over 5, obviously make sure you're in degree mode here. So what is inverse sine of 3/5? And it goes on and on, I imagine, right? Are we agreement? 36?
Yeah.
Rounded. Okay. So that's theta. According to this, the cosine of double that should be 7 over 25. So keep that answer in. Is the cosine of 2 times your answer, is that equal to 7 over 25? What is the cosine of 2 times that answer? Make sure you have that close parenthesis there. Go ahead, Trey.
The sign of double is.
It should be cosine.
No, that's what you're doing.
So cosine of 2 times 36.8699. Anybody? It's like 0.27. Okay. Give me one digit. One.
It's like 0.2, but it's like 999, so therefore you
It's
can
rounded up
round it up to 28.
2, 8, and then.
Okay, so it rounds up to 0.28. Now,
And not round it up to 629.
okay. Are they totally exact, or is there a little bit of rounding errors? There's a little bit of rounding errors. That's okay, because this is going to round, and when you double it, it's in the cosine, and that rounding is going to compound. 7 over 25, we can get it as accurate as possible. But this is a way that we can verify that we're on the right track. Does that make sense? What I like about this as a math teacher is it allows you to check your work, okay? But it doesn't allow you a shortcut way of finding the answer. You know what I mean? Because if you have 0.28 blah 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 blah, you can't just do math, enter, and get a nice 7 over 25. So there are some limits of technology. It's great. It's a real good way of verifying that we're on the right track, but it does have some limitations. So there you go. We might do one more example of this. This homework will not be due on Tuesday, but it'll be due on Wednesday. We'll probably just do one, maybe 2 more practice problems. I am going to give you the homework though, because frankly you've got enough knowledge you can do that. Today, very short lesson. We talked about 3 formulas. These are the double angle formulas, and we talked about how to use them.